Hey, good day, everyone. So, I'm going to present a novel approach of growing high-value crops like Lactuca Sativa, optimizing the solar sharing, smart illumination technology, consuming the renewable energy to address SDGs. So, this September 7, 2024, via virtual in Kuala Lumpur, Malaysia. I'm Dr. Myrtel S. Bernardo from Bulacan Agricultural State College, Philippines. So first we have the introduction. So the basis of the study is based on the Agricultural Decision Support Systems, or the ADSS framework. And this ADSS empowered farmers with a data-driven decision making. Through comprehensive framework, imagine a computer program that analyzes the real-time sensors with the data about the factors of the soil moisture, temperature, humidity, weather, forecast, along with the satellite image for the crop health. This also allows the recommendation of the optimal practices like planting schedules, irrigation strategies based on the actual need, target fertilizer application, and ideal harvest window. The farmers may be able to boost the crop yields, save expenses and wasteful resources usage, and lessen their environmental effects by utilizing this data-driven strategy, opening the door for a more data-driven and sustainable agriculture. This study aims to design and develop a solar smart lighting systems with tunable or controllable LEDs and sensors monitoring capabilities. It is also planned to conduct the control field trials comparing the growth of the crops under a new systems or conventional lighting in open field conditions. Third is this is intended to analyze the economic and environmental benefits of the systems. And finally, it is sought to assess how the system could contribute achieving the specific United Nations Sustainable Goals and of related with the food security, clean energy, climate change, and sustainable cities. This also incorporate the puzzle logic controller diagram, and this puzzle logic is for the lighting systems that is shown in the diagram. Basically, this puzzle logic is a type of artificial intelligence that automatically adjusts the lighting intensity by using sensor data and program parameters. Then sensors monitoring temperature and light levels, and the controller may be set up to stimulate the sunrise and the sunset. That could be the specification and classification of the optimal plant growth. This also study consider the factors of the sustainable agriculture that has the three components of the primary objective of it is the society, environment, and energy. These elements and ideas appear that the most definition of sustainable agriculture, although it's a wide range of ideologies, laws, and practices, these help achieve the objective. And these solar sharing lighting systems bridges the gap between the renewable energy and the LED lighting, and the solar panel gathered sunlight to transform into electrical energy and make sure that is the energy to power the LED directly. This eliminates the reliance of the traditional grid, the often powered and non-renewable resources, that it promote a clean and sustainable approach to lighting by harnessing the sun energy directly, and the solar sharing reduces the dependence in the fossil fuel and minimizes the environmental impact. In the methodology, so from that we have the harvesting of sunlight or the sun energy or the solar energy stored in the battery. Then we have the options of electric current if the insufficient light harvestance to ensure that the lighting is continuous for the plant growth, coupled with the sensors and the control systems with the Wi-Fi or the wireless fidelity and the IoT or the Internet Things technology with the IoT technology applications that monitor the light intensity with the calibration and the data-driven technology. So this prioritizing the SDGs with the zero hunger, affordable, clean and energy, decent work, economic growth, sustainable cities and communities, responsible consumption and production, and the climate change. The resulting discussion, so we have models, model 1, 2, 3, and the controlled one. The controlled one is no smart lightning or any technology applied on it. So it's stand alone. Okay. So we measure the height and the mass of the lettuce to ensure to see the comparative difference of the different models applied on the lettuce. So as you can see, the height is of 125, 253, 325, and 25 on the control. That significantly higher with the model 3 that uses the smart with the IoT. In terms of height in milliliters, we have 17, 20, 25, and 8. So with the IoT technology, it's much higher on the height. Oh. And next is we also have the photosynthesis coefficient of determination represented in R squared with the relation with the PPDF or the photoflux density and the daily light integral or the DLI, which represent that 0.08 has a strong correlation on it. Next is the sensory evaluation result. The attributes are the color, crunchiness, and bitterness. Okay? So as you can see in the diagram, so there is no significant difference between the so that could be a reference that the taste of the lettuce harvested with applied solar sharing smart technology is accepted. The nutrient analysis, so it is more than 2% higher than the Philippine standard established by the Department of Science and Technology, Food and Nutrition Research Institute, or the DOST FNRI. And return of investment with the cost benefit analysis and the ROI is much higher by 100.53 by 56%. As a summary, the sensory evaluation, the taste of the lettuce was accepted and addressed the SDG 2 in the food security. It's acceptable, so we can consume that. Then the nutrient analysis laboratory tests meet the Philippine standard set by the DST FNR. The renewable energy was used, or we gathered the solar energy stored in the battery, and as well as a solar sharing illumination, and it offers a clean energy on the study. And on environment, we have no insecticide or pesticide applied on it. Then it is an indoor farming that address the climate action. It is also a good business opportunity with the initial capital of $190 and the ROI of 104.56% and 9 harvests a year. So seeding the future with smart energy, smart agriculture is a very good start on it. On the conclusion and recommendation, so this study developed or established and developed the solar sharing smart lighting systems with smart LED and sensors for monitoring capabilities for the indoor farming tested on lettuce. And the computed coefficient of determination is also strong correlation. Second, the different models controlled were conducted in comparison, which has an acceptable taste, the illumination up to 90 years, and the nutrition value was accepted or meet the Philippine standards. The ROI is 104.56%, and we have 9 harvests per year. And lastly, this solar sharing smart contribute evidently on the UN SDGs for the zero hunger, for the food security, affordable and clean energy, optimizing the renewable energy by using the solar energy and the solar sharing, a decent work and economic growth for using this business opportunity, sustainable cities and commodities that could be used in our offices, our condominiums or hotel to have a setup like this and incorporate for your business as well as for family consumption. And responsible consumption and production, this could be a great opportunity to have this one. And a climate action as well. We can put this indoor. Today we encountered a typhoon and thing, but if we put your lettuce outside, it's already dead. But if we put our lettuce indoor, so safety, we have a food to secure on. Okay. From that, thank you for listening. And if you had more about smart agriculture on me, please contact me. My details are here. And thank you, everyone.